Alright, this lesson is going to be about something called z-score. Z-score tells you how many standard deviations you are above or below the mean. The mean always goes in the middle of the distribution. Alright, we're talking about normal curves, of course. Let's say if the mean on some particular test was a 70%. Alright. Let's say if the standard deviation was, 10, just to keep the numbers easy. Then that would make this 80, and this would be 90, okay, and this would be 100. And this would be 60, and 50, and 40. Okay? Now, if you have a score of, let's say, 80, this would translate into a z-score of 1. The reason why is because 80 is one standard deviation above the mean. Okay, this 90, anybody with a score of 90 would be said to have a z-score of 2, because that's 2 standard deviations above the mean. Alright, if you had a score of 60, you could say you have a z-score of -1. Okay, because you are 1 standard deviation below the mean. Let's say if you had a score of 55. Okay, well then you would have a z-score of -1.5. Okay, because 55, well, that is 1.5 standard deviations below the mean. So z-score is a number that tells you how many standard deviations you are above or below the mean. Okay, take a look at problem number 1. The heights of women aged 20 to 29 are symmetrically distributed with a mean of 64 inches and a standard deviation of 2.7. Men the same age have a mean height of 69.3 with a standard deviation of 2.8 inches. What are the z-scores for a woman 6 feet tall and a man 6 feet tall? Okay, so this is a good problem because it highlights the fact that you want to compare things that are similar, because if you talk about a man being 6 foot tall, okay, versus a woman being 6 foot tall, okay, at first glance, oh, they're both 6 feet tall. So in some sense, they're the same, okay, the same height. But really, what's more meaningful is to compare the height of a man to other men and compare the height of this woman to other women. Okay? Because what we care about most really is, are you tall for a man or are you tall for a woman? Okay? Turning this into z-score gives us a way to really compare and see, well, wait a minute, who's really taller? You know, not directly taller, but who's taller, you know, considering their gender? Who's taller compared to others of their same group? Okay, so let's split this up, and we'll do the men over here on the left, and we'll do the women on the right, okay? Turns out there's a formula for the z-score, okay? The formula is the z-score is going to equal the actual value, whatever you're talking about, in this case heights, minus the mean divided by the standard deviation. Okay, so again, the z-score is the value minus the mean divided by the standard deviation. So on the left here, we're going to do men, and on the right here, we're going to do women. Okay, so the men. If I want to find the z-score for the men, I'm going to have the z-score is going to equal? Okay, well, let's see. For this particular man, all right. What are the z-scores for a woman 6 feet tall and a man 6 feet tall? So in both cases, the x value here is the 6. All right, so there's our actual value is 6 feet tall. Minus the mean. Let's see. Men have a mean height of 69.3 inches. Oh, wait. That was pretty silly. Okay, so here this is in inches and this is in feet. So I definitely need to convert that. So fine. 6 feet tall. If I want to convert that to inches, I need to do 6 times 12. All right, there's 12 inches in every foot. 6 times 12 is 72. Why did I put 77? I don't know. Okay, but 6 feet tall is the same thing as 72 inches. Okay, so like I was saying, the man, 6 feet tall, or 72 inches. So I need to do 72 minus the mean, which is 69.3, divided by the standard deviation. Standard deviation of 2.8. Okay, let's just put that in our calculator and see what we get. Okay, I'm getting 0.96. And really, I'm going to leave it at that, 0.96. Okay, so that's the z-score for this man. Okay, now let's do the z-score for this woman. Let's see. Okay, the woman is still 6 feet tall. It's still 72 inches, so 72 minus. Now let's see. The mean for women is 64. Okay. So the mean is 64. Now the let's see. The standard deviation is 2.7. Okay, so that is a z-score of, I'm just going to put this in my calculator. All right, that's a z-score of 2.96. Okay, so just for easy comparison of where these, where this man and this woman fall along the population, compared to their same group. The man has a z-score close to 1. So he's a little bit tall, okay? Looking at our chart here, all right, looking at z-scores will allow us to compare the man and the woman directly and see like which one is really taller for their group. Okay, now the mean, of course, is represented by this middle number. Okay, but since we're doing a z-score, the z-score in the middle is always going to be 0. Okay, and here we're always going to have z-score 1, 2, and 3, and we're always going to have z-score -1, -2, and -3 every single time. Okay, so let's see, where did the man fall along the z-score curve here? 0.96. Okay, that's almost 1. Okay, so the man was, he's right about here. Okay, so he's tall. He's taller than your typical man. But now, where did the woman fall? Her z-score was 2.96. That's almost 3. Okay, so the woman, even though she was the same exact height, all right, 6 feet, 72 inches, when you compare her to her peers, all right, other women, you see that she is actually much taller than the man. She's not actually taller, they're the same height, but among women, having the height of 6 feet is much more unusual. So As women go, she's much taller than the man. Okay, she's much taller than a typical woman. Okay, she's 3 standard deviations taller. He's tall for a man, but he's just a little bit tall. She's really tall for a woman. Okay, so z-score allows you to compare more easily two values that normally are not that easily compared, like men and women. All right, moving on. Yeah, they also asked, describe what information the z-scores give that the actual heights do not. The z-scores tell us that the woman is much taller compared to other women. Okay, the heights don't tell you that by themselves. Okay, all right, number 2. A study of elite distance runners found a mean body weight of 63.1 kilograms with a standard deviation of 4.8. Assuming that the distribution of weights is normal, make an accurate sketch of the weight distribution with the horizontal axis marked in kilograms. Be sure to label the mean as well as the points 1, 2, and 3 standard deviations away from the mean on the horizontal axis. Okay, so this is like what we did yesterday, or in a previous lesson, whichever way you want to think about it. I'm going to cheat a little bit and just cut and paste. All right, of course, you will need to draw your own curve, as we've done many times before. Now, the mean is going to go right in the middle. So, all right, the mean is 63.1 kilograms. Okay, and make sure you label this. The x-axis, this is kilograms we're talking about. All right, now the standard deviation is 4.8. Okay, with that in mind, I can find these other values by adding or subtracting 4.8. Okay, so if I do 63.1 plus 4.8, I have 67.9. All right, if I add another 4.8, now I have 72.7. And if I add another 4.8, I get 77.5. Okay, now if I subtract 4.8, so 63.1 minus 4.8, that's 58.3. All right, minus 4.8 gives me 53.5. And minus 4.8 one more time gives me 48.7. This is what they mean by showing the values 1, 2, and 3 standard deviations away from the mean. Okay, so I think we've done part A. All right, now part B. What percent of runners have a body weight between 48.7 and 67.9? Okay, now before I do that, I need those percentages. According to the empirical rule, which we just memorized, if we have a normal distribution like this, we can just memorize the percentages of the data that fall in each one of these categories. For example, this zone is a 34% zone. And same with this. In fact, maybe I'll just stick to one side. So I have 34%. Next, I have 13.5%. All right, next I have 2.35%. And finally, I have 0.15%. And that's going to be the same in the other direction. So 13.5% 2.35%, and 0.15%. Okay, I've memorized all of these values. You make sure that you have as well. So with those values in mind, what percent of runners have a body weight between 48.7 and 67.9? Okay, fine. Well, 48.7 is right here, and 67.9 is right there. So I could just add up all these percentages, okay? So I see that middle percent there is 68. So I'll do 68 plus 13.5 plus 2.35. I'm getting 83.85. How about you? Okay, so 83.85%. Okay, what's next? The Army reports that the distribution of head circumference among male soldiers is approximately normal with a mean of 22.8 inches and a standard deviation of 1.1. Okay, draw a sketch to help you with the problems below. Alright, well here comes my sketch. They mentioned the mean is 22.8. Alright, so that means I will have 22.8 right in the middle. Okay, the standard deviation is 1.1. Why did I put 1.5? I don't know. Okay, so 22.8 plus 1.1. All right, of course that is 23.9. And then 25, and then 26.1. All right, now going in the opposite direction, I will have 21.7. All right, I'm just subtracting 1.1 over and over again. That's going to be 20.6. And 19.5. Okay, this should help me answer these questions. Let's see. A soldier whose head circumference is 23.9 inches would be at what percentile? Okay, 23.9 is right here. When we talk about percentile, we talk about how much of the population is below that particular number, okay? Now, one more time, putting those decimals back in there. This is 0.15. And let's see, 2.35. And this is 13.5. And 34. 34. I might as well follow through. 13.5, 2.35, and 0.15%. Okay, so anyway, this yellow part that we just decided is going to give me the percentile. It's always the part that's less than the number in question. So all the way up to the blue median here, the mean, that's 50%. So it's just 50% plus this one more zone, 50% plus 34. So that's 84%. Okay, so we would say, well, he's in the 84th percentile. Okay, part B. What percent of soldiers have a head circumference between 19.5 and 25? Let's see. 19.5 and 25. Well, here's 19.5 right here. And there's 25 right there. Okay, so I could just add up these 1, 2, 3, 4, 5 numbers. I could add up those 5 numbers. But another little just small shortcut I could use is, look, from 20.6 to 25. This is a number that I have memorized, okay, because that is 1, 2 standard deviations. 1, 2 standard deviations in both directions. And I know that 2 standard deviations in both directions is 95% of the data. All right, so that's 95% right there. So that's all of this yellow that I just highlighted, except for the 2.35%. So all I have to do is add that on. Whoa. All I have to do is add on that one more little zone, and then I'm golden. Okay, and that should be my answer. So that's going to be 97.35% altogether. Okay, that's the answer to part B. All right, new problem. Okay, we're talking about the distribution of an intelligence scale scores for young adults. We got the mean right here. I should highlight that. All right, we've got the mean and we've got the standard deviation. Okay, now if someone's score was reported as being in the 16th percentile, what score would that individual have? Draw a sketch to help. Well, let's label this up. Let me zoom in a little bit more. Okay, the mean is 110, so that's going to go right here. My standard deviation is 25. So if I add 25 each time, that's going to give me these numbers right here. All right, if I subtract 25 on this side, this will give me these standard deviations. All right, here's a sketch that's going to help me. Okay, so the 16th percentile. All right, now remember your percentages that we talked about before. All right, starting right off, we have 0.15. Okay, that was not a good one. We have 0.15%. Okay, and then we have 2.35%. All right, and then we have 13.5% and 34%, and so on. Let's go with this so far. Now, if I want to know where the 16th percentile is, I need to start adding up these numbers from the left. Okay, so obviously to here is just 0.15%. But if I go 2 zones, okay, so far that is 0.15 plus 2.35. All right, so far I'm up to 2.5%. Okay, I'm shooting for the 16th percent, the 16th percentile. So I must clearly keep going. If I go ahead and add one more zone, so I take my 2.5 and I add the next zone, which is 13.5. Whoa, I missed that. I say 13.5. And boom, there I have 16%. So it looks like to have 16%, I need my first 3 zones. Okay, let's see. I don't know if this will even be visible. Okay, but we get the first 3 zones. There's your 16%. Okay, so as far as what value is the 16th percentile, it's this cutoff right here, 85. 85 is the 16th percentile. All right, a score of 85 would be the 16th percentile. Okay. All right, answer the same question for the 97.5th percentile. Okay, well, so far I've got 16%. Let's just add one zone at a time until I get it. Okay, let's see. How'd this get so small all of a sudden? Hold on. All right, so if I take my 16% and I add on one zone, obviously that is 50%, okay? How do I know without adding? Well, I'm right to the middle. The middle is half of the distribution. That's 50%. So that's 50% so far. So let's go ahead and add another, because I'm trying to get to 97.5. So if I take my 50% and I add another 34%. Oh, that's big. All right, then that brings me up to 84%. All right, I'm still shy of my 97.5. So let's take it up another notch. All right, if I add my next zone is a, hold on, is a 13.5%. Okay, so if I take my 84% and I add my 13.5, turns out 84 plus 13.5 is 97.5. Okay, so this is how much I need to get my 97.5%. All right, I'll just modify this as long as I'm doing it. Okay, so from here to here, that's our 97.5%. Okay, so what number? It's the 160. Okay, so a score of 160 would be the 97.5th percentile. Problem number 5. This problem seems a little difficult. The distribution of weights of loaves of bread from a certain bakery follows approximately a normal distribution, meaning bell curve. Based on a very large sample, it was found that loaves with a weight of 15.34 ounces had a z-score of negative 1.28, and loaves with a weight of 16.31 ounces had a z-score of da-da-da-da. All right, what are the mean and the standard deviation of the distribution of the weights of loaves of bread? All right, thank goodness for the hint here. We need to set up 2 equations and solve the system using substitution. Okay, so let's try for that. Okay, so let's start with the first one. Okay, so we have with a weight of this many ounces, this was the z-score. Let's start with those two. Okay, remember the formula for z-score is z equals the value minus the mean divided by the standard deviation. Okay, now if I plug in these values, all right, the weight is 15.34. Okay, so that's going to go right here. All right, so 15.34 0.34. Okay, minus the mean. And the z-score is negative 1.28. Okay, so this is going to equal negative 1.28. Alright, so this is all we got right here. We can't solve this. But then, thank goodness, they gave us another pair of values. Okay, the other pair of values is when the weight was 16.31 ounces, the z-score was 0.84. So plugging those in, all right, I have a z-score of 0.84 equals 16.31 minus the mean divided by the standard deviation. So I need to solve this system of equations using substitution. Okay. I'm going to start by flattening both of these equations out. Alright, so imagine that I multiply both sides of the equation by the standard deviation. Okay, so I'm going to do standard deviation on both sides. That way those will cancel out. Alright, so far I've got negative 1.28 standard deviation equals 15.34 minus the mean. Now I'm going to go ahead and get this mean by itself. Okay, by subtracting 15.34 from both sides. Okay, I can't put these together because they're not like terms. This one has standard deviation, this one doesn't. But what I have so far is negative 1.28 standard deviation minus 15.34 is equal to negative mean. Now, we don't want even this negative sign here, so I'm just going to multiply through everything by negative 1. Okay, which basically means I'm going to change the sign. Or you could think of it as dividing everything by negative 1 if you want. Maybe that's easier for you guys. But anyway, all the signs are going to change. So I have 1.28 standard deviations plus 15.34 is equal to the mean. Okay, so far so good. Next time I get a chance, I could plug this in somewhere. Alright, I need to do the same thing over here. So I'm going to start by multiplying both sides by the standard deviation. So I'm going to do the standard deviation on both sides. That way these cancel out. Okay, so I'm going to have 0.84 standard deviations equals 16.31 minus the mean. Alright, subtracting 16.31 from both sides. Again, these are not like terms, so I just write them side by side. So 0.84 standard deviations minus 16.31 is equal to negative mean. Once again, I am going to divide everything by negative 1. Okay, because I need this to be a positive mean, just a plain old mean. Okay, so that's going to give me negative 0.84 standard deviation plus 16.31 is equal to the mean. Alright, now here's where it's time to do my substitution. Alright, I'm going to take this, alright, which is the value of the mean, and I'm going to plug it in. Can I get it to scroll like this? No, guess not. I'm going to plug it in all the way over here, right there. Okay? So basically I'm going to wind up setting these equal to each other. So in fact, think I'm going to bring it over here. So these are both equal to the mean. So I'm essentially going to wind up setting these equal to each other. So I'm going to have negative 0.84 standard deviations plus 16.31 equals this, 1.28 standard deviations plus 15.34. Okay, I bet that I can solve this for the standard deviation. So I would start by, I see I got my variable on both sides, so I'm going to do the opposite and add 0.84 standard deviations to both sides. Okay, let's see what we have now. So 1.28 plus 0.84. Okay, so I'm getting 2.12 standard deviations. Okay, just bring the rest of it down. Okay, I'm trying to get standard deviation by itself now, so I could now subtract 15.34 from both sides. So I've got 2.12 standard deviations, and I'll just do the subtraction over here. 16.31 minus 15.34. So I'm getting 0.97. Okay. Now I'm going to divide both sides by 2.12. Okay. So let's see, 0.97 divided by 2.12 is giving me 0.4575 4717. Not sure how many decimals I'm going to need, so I'm just going to keep them all for now. That's my standard deviation. Okay, now I need to find the mean. Okay, well, we have our mean. We have two different equations that we could use for the mean. All right, I'm going to use this one just because it's all positive numbers. So my mean should equal 1.28 times the standard deviation. So I'm doing, so my mean here should equal 1.28 times, maybe I'll just finish writing it, 1.28 times standard deviation plus 15.34. Alright, so that means my mean should equal 1.28 times 0.45754717 plus 15.34. I'm sure I don't need all of these decimals. I probably could have gotten away with 4 decimal places. Alright, I'm just being extra thorough at the moment. Okay, so why don't you try it with 4 decimal places and see how close you get to the same thing as that I get. So 1.28 times 0.4575 4717 plus 15.34. Okay, so I'm getting a mean of 15.90, All right, it's 15.92566. But since this is the final answer, I am going to go ahead and round this now. So 15.93. Whoops. Okay, so we have a mean of 15.93 and a standard deviation. And now that I'm at the final end, I will go ahead and round this. A standard deviation of 0.46. Okay, man, that was a long and difficult problem. I'm not feeling that one. But hey, we got to do what we got to do. All right, last problem. We got this phone company. It listed the long distance rates for 24 countries. There they are. We've got the mean and we've got the standard deviation. Okay. Now we want to know what about Israel's position within this distribution using its z-score and a complete sentence. Okay, so Israel. Where is Israel? Where are you? Okay, here's Israel at 8.9. Okay, and there's the mean right there. Okay, so let's calculate the z-score using these numbers. So let me just get these values down where I can see them. So Israel's value is 8.9. Okay, the mean is 13.68. And the standard deviation is 11.56 cents per minute. All right, now let me zoom in and calculate some z-score. Okay, so we know that the, let me just change colors for a second. We know that the z-score is going to be the value minus the mean divided by the standard deviation. Okay, so in this case, that z-score is going to be the 8.9, all right, minus the 13.68, divided by 11.56. All right, so just putting that in my calculator. All right, 8.9 minus 13.68 over 11.56. Okay, I'm getting a z-score of negative 0.41. Okay, there's my z-score. All right, obviously that tells me that this is below the mean. Okay, it's a negative number. It's not a full standard deviation below the mean. In fact, that it's not even quite half a standard deviation below the mean. Okay, so you know, if we were looking at one of those distribution curves, all right, if I'm looking at a z-score distribution, of course I'll have 0 in the middle, then Israel is going to be right about here. Okay, so that puts Israel a little bit below the mean, but it's less than half a standard deviation below the mean. So let's put that into a sentence. Okay, and here's how you might write that as a sentence. Israel's rates are a little less expensive than a typical country. Their rates are almost half a standard deviation below the mean. All right, and that was the last problem on this assignment. I hope it was helpful, and I will see you on the next video.